Here we have a triangle ABC which is right angled at the vertex C. Now for the mathematical notation of vertices of a triangle, we always use uppercase alphabets or the capital letters. And now to denote the measurement of the sides, we use the same alphabet as the opposite vertex, but in the small case, the smaller letters. So if this vertex is B, the measurement of the opposite side is also given in B, but in small letters. So this measurement will be B, this measurement will be what? It will be C, but in smaller letters, and this will be also A. Now we have a line C.D. which connects C and its opposite side A.B. perpendicularly. Now tell me, what is the mathematical term for a line which joins a vertex and the opposite side perpendicularly? We call it the altitude, right? So even though it is not mentioned, keep in mind that CD is the altitude to the base AB. And what is its measurement? Its measurement is given as P in meters or centimeters, whatever. Its measurement is given as P. Now what we have to prove is 1 by P square is equal to 1 by A square plus 1 by B square. Now usually when you apply the Pythagoras theorem, you can apply it here, right? You see here AB is what? It is the hypotenuse. Its measurement is C. So applying the Pythagoras theorem, you can get C square is equal to A square plus B square. We can apply it. But when you apply the Pythagoras theorem, what you will get is the sum of the squares of sides. But what you have here is the sum of squares of the reciprocals. So it is not a direct application. In such cases, when you do not directly get an answer, try reversing your steps. If your last step is going to be 1 by P square is equal to 1 by A square plus 1 by B square, start reversing the steps. If your last step is this, if your final result is this, what do you think was the previous step? Try reversing your steps. It may be unconventional, but it is not illegal. The maths police is not going to catch you for this. There is nothing you can do to 1 by P square, so that you write as it is. But here what can you do? Take the LCM. The LCM will be A square B square, and your numerator will be A square plus B square. But then what is A square plus B square? So maybe the previous step was looking like this. It is 1 by P square, and maybe it was looking like this. What can you do from this? You can cross multiply, right? So maybe what you have to do is cross multiply. There you have got two squares are equal. Then maybe you can take the square root. While taking the square root, you don't have to worry about the negative square roots, because here we are dealing with distances. So we have to worry only about the positive numbers. So there it stops. From here, where do you go? BC is equal to AB, finished, end of story. So we will look carefully what is PC and what is AB. Now if you take B as the base, then what will be its corresponding altitude? Its corresponding altitude is going to be A. Now the same, if you take AB as the base, then what will be its corresponding altitude? Its corresponding altitude will be P. So you see what is happening here? Where have you seen base into altitude? When you consider the area of a triangle ABC, it is given by half into base into altitude. This is where we have seen that area of a triangle, the same triangle, but it can be expressed in three ways, because it has three vertices. If you take B as the base, A is its altitude. If you take A as the base, then what will be its altitude? If A is the base, its altitude is B. If you take this as the base, AB as the base, then its altitude is CD. So the same quantity expressed in 3 different ways. So just multiply throughout by a half BC is equal to a half AB. This is how your whole thing started. You had expressed the area of ABC in 2 different ways. Then what? Multiplied throughout with 2, squared it, cross multiplied it, took the here you took the LCM, but here what you did is split the fraction into 2 and you have got the answer. Now as I said, it is unconventional but it is not illegal. So that's all for today. Take care. Assalamu alaikum.